Hi, I'm Stephanie Pollock, and today I'll be explaining how to do question 14 from page 247 in chapter 4, Derivatives of Sinusoidal Functions. First of all, what is calculus, and why do we need it? Well, calculus is a branch of math that studies the rate of change. Being able to determine this information makes calculus very applicable to a broad spectrum of people, such as architects, graphic designers, and electrical engineers. Bringing us to our question that deals with AC/DC circuits. In North America, the voltage is described by the function V at t is equal to 170 sine 120 pi t. Find the maximum and minimum voltage levels and the time which they occur. Then, the period, t in seconds, the frequency, f in hertz, and the amplitude, a in volts. Finally, use this information to compare the standard wall socket voltage signals of Europe and North America. Solving a problem like this is very common for electrical engineers, as they need to ensure the safety for people using electrical outlets. Before we can begin, we need to have two basic ideas. One, what a sinusoidal function is, and two, what differentiating is. A sinusoid is a mathematic curve that describes repetitive oscillation. In other words, the graph is moving up and down from max to min. For example, this is a sine graph. The process of finding a derivative is called differentiating. A derivative is a function that models the instantaneous rate of change at every point of the function. Geometrically, the derivative at a point equals the slope of a tangent line to the graph's function. Mathematically, you can find the derivatives using things like the chain rule. Now, before you begin solving, you should know exactly what you're solving for. Max and min values are the most positive and most negative points in the graph. It represents the maximum or minimum voltage put out by the North American signal. Their time is signified in the x values, as this is the time at which the max or min can occur. Amplitude is the maximum extent of oscillation from equilibrium. Period is the horizontal length of one cycle measured in seconds. And finally, frequency is the number of cycles per second. It's also the reciprocal of a cycle. To ensure you do this right, you should break your problem down into steps. First, identify your givens. Second, identify what you're required to find. 3, figure out a solution to this. And 4, remember a sentence answer, because this is an application question. The question provides us with this equation. V at t is equal to 170 sine 120 pi t. Through this equation, we know both the a and d values. So, we can use this to find the max and min, which would be a plus d is equal to 170 volts plus 0, because there is no d value, is equal to 170 volts, and the opposite signs for the min. However, this method does not give us the time at which the max and min voltage occur. So, we can use method 2. In method 2, you're going to find the derivative, then set it equal to 0. Next, using your sinusoidal graph, identify the points in which the max and min equal 0. To find the derivative, use a mix of the chain rule as well as the sinusoidal properties of v at t is equal to sine x. The derivative is v at t is equal to cos x. As you can see, pi over 2 and 3 pi over 2 are equal to 0. To identify if it's a max or a min, look at the graph again. The tangent to the derivative at pi over 2 has a negative slope, which implies the second derivative will also be negative, concluding that pi over 2 is a maximum. Conversely, 3 pi over 2 has a positive slope, implying that the second derivative is also positive, meaning 3 pi over 2 is a minimum. The properties of this graph is it will continue to oscillate up and down. Therefore, there is multiple times where it will reach the maximum and or minimum voltage level. An individual can use sequencing to determine an equation to determine the time of max and mins at any point along the graph. As long as k is greater than 0, it can be any number. Don't forget your sentence answer. Next, we're solving for period. Remember your steps. We're given v at t is equal to 170 sine 120 pi t. 120 pi just happens to be the v value, which is needed in the equation t is equal to 2 pi over b, which leads us to 160 seconds. Therefore, the period of this function is 160 seconds. Next, we're solving for frequency. Our givens in this case is period, as period is the reciprocal of frequency. Therefore, the frequency is 60 Hz. Lastly, we need to determine the amplitude. As we discovered when searching for the max or min, amplitude is right in the equation represented by the value a. However, there's also equations if you'd like to confirm this. Amplitude is equal to the max minus the min divided by 2, which is 170 volts minus negative 170 volts divided by 2, which is 340 divided by 2, which is indeed 170 volts. Now that we have all this collected information, we can finally compare the European and North American voltage signals. As you could tell, both of them were sinusoidal functions, and sine functions of that, both starting at 0, 0. However, they both had different maximum voltages. European has 325, where American has 170, as well as the max and min occur at different times. Also, there was different periods, frequency, and amplitudes of the function. Thus summing up our problem. So, it is evident that calculus is very important to succeed in little math problems, yes, but also succeed within the worldwide community.